So question one, the first thing we want to observe is we're looking for an estimate. And an estimate means we don't have to use a calculator. In fact, it should be done without a calculator. So any math should be something we could do in our heads without using a calculator. So we want the amount of work done when a student drags a box with a force of 12 newtons for 85 meters. So our formula is work, force times distance. The force is 12 newtons. So as we're going to do this math in our head, I'm going to round that down to 10 newtons to make it easy, and it's 85 meters. Since I took that one down, maybe I'll take this one up and I'll say it's 90 meters. So we have 10 newtons times 90. So then we would estimate the amount of work is about 900 joules. So I could clearly and easily do this math in my head. So now we work on to the part where we're doing calculations. All right, so we've got two friends on Insta. They're doing yard work. And the friend in Allendale says that she dragged 24 bags of leaves. So here are these bags of leaves. There are 24 of them, like so. She drags them 75 meters to the curb. And she measured how much force was applied in dragging each one, and she found it was 146 newtons. So that's what we have for the Allendale student, and we want to know how much work did she do on each trip to the curb. Well, that work will be the force times the distance, and the force is 146 newtons, and the distance is 75. So 146 times 75 is 10,950 joules. So that is the work that they did, 10,950 joules. And now we're asked, how much did she do overall? Well, that was for one bag, so that's per bag. And we had 24 bags times 10,950 joules per bag. And we see then that the bags will cancel. And we multiply by 24. And we get 262,800 joules. So each trip and overall. We'll come back and deal with significant digits for all the questions at the end. So what about the Ho-Hocus friend? Well, the Ho-Hocus friend, I had it way worse than you did, because she dragged 24 bags of yard waste. Same again, 24 bags. 75 meters. But she dragged 2 bags at a time. And the spring scale said 292 newtons. So if we look at the work done each trip, we have force times distance. The force is 292 and the distance is 75. And so that's 21,900 joules. So each trip to the curb, that friend did 21,900 joules. Well, how much overall? Well, if she was doing 2 at a time, then that means there are 12 trips. So 12 trips, and this 21,900 joules is for a trip, each having 2 bags, times 21,900 joules per trip. And we again get 262,800 joules. Our last question, was the Ho-Hocus friend correct? That she had it worse than her Allendale friend? So this is kind of a complicated answer. So, in terms of total work done, So no in terms of total work done, because both of them did 262,800 joules of work. Yes, in terms of the force required to drag the bags, because the Hohokus friend had to use twice the force. On each trip, even though she had to make only half as many trips. The last question, express your answer to number 2 in kilo units. So, answer number 2, we had 262,800 joules. Well, 262,800 joules. Well, what we would know is we want our answer in kilojoules. So we want kilojoules on top and joules on the bottom. And what we would know is 1 kilojoule is 1,000 joules. So you can see then when we do the math on this, we're going to be left with 262,800 over 1,000, and it'll be that many kilojoules. Well, these zeros cancel. Then we're dividing by 100, 1, 2. So we end up with 262.8 kilojoules. With the decimal place here, it's 262.8 kilojoules. So now we're going to go back and take a look at the significant digits. This one's a little harder than some of them we've seen in the past. In our question number 2, we have 3 digits and 2 digits. 3 digits, 2 digits. So that means our final answer can only have 2 digits. So we look at the next decimal place here, and this 9 would cause this to be rounded up, which makes it look like the answer should be 11,000 joules per bag. But when we write 11,000, it looks like it has 5 digits, 5 significant digits in it. How we express this to 2 significant digits is we must write it in scientific notation. So 1.1 times 10 to the 4th joules per bag. And if we look at this answer, since it must have 2 digits, it must be 2.6 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5th joules overall. So although we could get full credit for calculating the right size answer, with the correct number of digits, it's this, as is this. Applying the same process down here, we have 2 digits and 3 digits. Our final answer could have 2 digits. So we are left with 2.2 times 10 to the 4th joules per trip. And this is 2.6 times 10 to the 5th joules again. And that means in the end here, we would have to say it's 260. So representing this with 2 significant digits, it looks like we want to say 260. But in reality, we have to express it as 2.6. 2.6 times 10 to the 1, 2, times 10 to the 2nd kilojoules. So when we deal with big numbers in physics and calculations, we have to use scientific notation. Otherwise, we'll be misrepresenting the number of significant digits.